Hi, welcome to Realize Live and this virtual session on cutting-edge manufacturing in Solid Edge. I'm Jim Wright, and I'll be walking you through this presentation. I'm a manufacturing business product manager, but I'm also part of the global technical enablement team, so that means I get to use the software quite a bit. Our agenda for today is additive manufacturing, 2D nesting, and of course, Solid Edge CAM Pro. Let's start with additive manufacturing. Solid Edge now has a new tab called 3D Print. We added this tab because we're expanding our 3D print capabilities, and so we've added the new tools to this tab, but we've also put some of the existing tools on this tab where they make sense. For example, we have existing clipping tools, but those are also great for viewing print slices to examine what your print would look like. We have new additive manufacturing design prep tools and some validation tools. Let's walk through them. One of the items we have that is new is physical threads. When you're 3D printing, a symbolic thread simply won't do. So now we can create a physical thread which can be 3D printed. This physical thread option is also available inside the thread command, so you can toggle from a symbolic to a physical thread. We have several new 3D print validation checkers. One of the new 3D print validation checkers that we have is for wall thickness. We have discovered that thickness of walls is a very important criteria for 3D printing. In fact, 3D printing bureaus report that 1 in 5 orders received cannot be created due to incorrect wall thickness, usually too thin. Checking wall thickness will help you avoid errors while 3D printing. Another checker we have is overhang angle. This helps you validate the design for 3D printing. After all, you can't just print material in space, it has to be supported. So this option helps you find out those areas that will need support. Delete voids is another great checker. If you have a model with a void in it, that can be bad for certain types of 3D printing. For example, if you're doing stereolithography printing, you don't want molten liquid inside of your model. The same is true for powder-based 3D printing. You don't want to have leftover powder inside the model. The reorient command allows you to adjust the orientation of the model in the virtual 3D print bed. This gives you a good opportunity to find the proper orientation along with our other checkers. New, you can now import OBJ files. These are very useful for additive manufacturing, virtual reality, and 3D graphics. You can also export to OBJ file format, which gives you an additional 3D printing format to use. Let's take a look. The reorient feature gives us a mock-up of the 3D printing space with our model inside of it. We can try different configurations of orientation. We can move and rotate the model so that it's presented in the 3D printer in a different way. It isn't necessary to get the model exactly right. We have a button that will auto-settle the model on the platen. Let's go back and check the overhang now. Okay, that looks much better. There is much less support required in this orientation. Remember, the bottom of the model is resting on the platen and doesn't require extra support. Now, let's check minimum wall thickness. We can toggle the overhang display back off, and then we can cancel this dialog. Our Delete Voids tool automatically shows and eliminates voids. We can use it now. There's the void. And let's just click the green arrow to get rid of it. The void is gone. It looks like our engineer started the process of putting threaded studs on our model, but forgot to add the actual threads. We can do that very quickly. Notice that Solid Edge automatically suggested a thread based on the size of the stud.
Our requirement is for M7 by 0.75, so we will select that. These are symbolic threads. Symbolic threads are fine for most applications, but in this case, we need real threads modeled on the studs so that we can 3D print them. Fortunately, another new feature in Solid Edge 2020 is physical threads. We can change the nature of these threads as we create them.
Next up on our agenda is 2D nesting. What is 2D nesting? Well, this is a new product for our Solid Edge portfolio, so I thought I'd take a moment to explain what it is. 2D nesting applies to sheet metal, for sure, but there are lots of manufactured items that are made from simple two-dimensional shapes. 2D nesting is the process of placing those 2D shapes efficiently into a sheet so that they can be cut out. Dress patterns have been done this way for decades. So here's a little quiz. Given that we need 4 of each item below, and we're assuming that they're all the same thickness and material, which nesting is more efficient? Manual placement or using a software algorithm? Well, obviously, the software algorithm is more efficient. Less waste and more reusable sheet material for the next job. In fact, when it comes to complex shapes or a lot of shapes, it's frankly impossible to place them manually with any kind of efficiency. So you must have a 2D nesting algorithm. Why do we call it 2D nesting? Well, the shapes are not really three-dimensional at all. They're two-dimensional sketches, and the thickness isn't relevant to the models that the sketches represent are the same material and are all the same thickness. The new Solid Edge 2D nesting program has many benefits. It's a standalone product as long as you're only working with DXF or DWG files. But it will also work with Solid Edge files, automatically extracting the flat patterns from sheet metal and the blank patterns from part files. It eliminates the tedious process of saving DXF files manually. It also improves quality because you are ensured of getting the latest data rather than an out-of-date DXF file. This may not be the most efficient nesting algorithm on the planet, but it beats everyone we've tested against. And material cost savings can be substantial on a product like this. It utilizes continuous nesting improvement until you stop it. You can also set it for a fixed run though. The return on investment could be very high based on material cost, and it can nest into multiple sheet sizes, which not all nesting programs can do. This will help you reduce leftover sheets, also called tailings, sometimes called partial sheets. The user can select the best nest from the list, not just the latest one that the 2D nesting algorithm created. It also does a great job of nesting inside of openings, and that helps to increase sheet usage and decrease waste. It has some great summary and detail reports that can be used as setup sheets for the shop floor. Let's take a quick tour of the product.
In this particular case, we're looking for part files that are made of 304 stainless steel that are 14 gauge thick. Now, let's start Solid Edge 2D nesting. We can start Solid Edge 2D nesting either from inside of Solid Edge or as a standalone application. Let's bring in some Solid Edge files. These files are sheet metal files that have already had a flat pattern created for them. That's another great benefit of this product. There's no need to save DXF files manually. The progress bar lets us know that this work is occurring. Another benefit of Solid Edge 2D nesting is that it can extract data from PSM or PAR files. That means it can handle lots of different types of industry requirements. Solid Edge 2D nesting has analysis tools to help us do our job. Each file has an indicator. Let's take a look at the yellow flags. That part's okay, but this part has a real problem where the edge of the sheet metal part has been chamfered. We'll discuss this with the engineer, but for now, we'll remove it from the list. The last file has a very small notch in it. That could be a problem, but for a water jet machine, that's okay. Solid Edge 2D nesting doesn't limit us to just Solid Edge files. We can also open DXF or DWG files, and they can be combined into the same job. Once the data is in Solid Edge 2D nesting, we can do analysis like what is the longest part and what is the widest part to make sure they'll fit on our water jet cutting machine. Another great benefit of Solid Edge 2D nesting is that it can incorporate multiple sheet sizes. This is something that other nesting programs cannot do. This results in much less wastage, as we will see later. We are now ready to begin the nesting process. We can either run the process for a fixed amount of time or let it run until we stop it. Let's go. We see results immediately, but we also see the constant improvement process in action. Each nest is more efficient than the last. After we stop the nesting process, we can look at the individual nests that we've created and choose the one that best fits our needs. We can even examine details such as where individual parts are placed inside of each nest. Now we will select the nest for export back into Solid Edge. Notice that I'm choosing a nest with a very small leftover. That's so we won't have that leftover sheet stock problem in the shop. Now, export to Solid Edge. We will export the sheet outline and output all the data into one file, although we could have each nest as a separate object in Solid Edge. We can also export the data into a DXF or DWG format if you need that. Because these are all PAR files, we can use synchronous technology to take the sheets and convert them back into solid models. Let's examine one of the files now. Here you can see that it is 2D sketches arranged in a part file. Since these are all valid sketches, we can very quickly use synchronous technology to create solid models from them. Solid Edge nesting works with Solid Edge files, but also neutral data formats like DXF and DWG. It automatically extracts the required data and is a very efficient nesting algorithm. Quickly export your data into a Solid Edge format or a neutral format. You can also nest into multiple sheets, which reduces the tailings or partial sheets. All these factors combined give you a return on investment that is very high.
NX users can use Solid Edge 2D nesting also. You would need to export the flats in the NX file as a DXF or DWG, and then you could perform the nesting as normal, and then import that nested data back into NX. Here's an example movie of how to do that. First, we create the flat patterns for the NX file. Then we export that flat pattern. We bring that flat pattern into Solid Edge using the DXF DWG format. And then continue on with nesting as normal. Now let's take a look at some of the great enhancements in Solid Edge CAM Pro. Flat dialogues give you more information readily available at your fingertips. Also called Explorer-style dialogues, these follow common usage of other CAM systems, so they help reduce the learning curve. And they use machinist language wherever possible. So, it speeds programming of chamfers in 2.5 axis mode.
Solid Edge CAM Pro has a new operation type. It's expressly for machining chamfers on prismatic parts. It's easy to use and really speeds up the process. Solid Edge CAM Pro also has great tools for selecting geometry. In this case, the pop-up tool gives us the option of selecting all tangent faces. In this case, that's perfect. Another operation already done.
Solid Edge CAM Pro has some great new post-processing capabilities. The post configurator can now support multi-channel or multi-function machines. It has an inspection tool for faster post development. It also features faster post-processing of large 3-axis toolpaths. And there's even more exciting news regarding post-processors coming in the next release. Stay tuned for that. For machining simulation, Solid Edge Cam Pro is world-class. It has some great tools to give you confidence that what you see on the screen is what will happen at the machine tool. Finally, I want to show you how we can do a round trip on our threaded hole pitch attribute by taking it into
which
Solid
allows
Edge
you to
Cam
make
Pro,
sure
that the hole pitch transfers from Solid Edge to Solid Edge Cam Pro, regardless of whether you're using the JT pathway or the native pathway.
Now we can continue our manufacturing workflow by cutting out these shapes on our water jet machine. First, we can extrude these 2D shapes back into physical objects. Solid Edge with synchronous technology makes this job easy. We'll extrude them for a distance of 2 millimeters. Great. Now we're ready to send them to Solid Edge Cam Pro. Solid Edge Cam Pro doesn't have a water jet machine in its out-of-the-box configuration, but it does have great tools for customization. So we built a water jet machine configuration. Let's test it out. There's our new template for water jet cutting. Since 2.5 axis machining is simpler than other types, we have modified our setup template for maximum efficiency. For instance, we already have an operation with the cutting width of the jet defined. Feed rates are also set. All we need to do is select the geometry. We'll select these 5 pieces as the workpiece. Solid Edge Cam Pro can easily deal with multiple workpieces. To simulate the raw stock, we're using bounding block, which automatically adjusts to the length, width, and height of the object selected. The height is okay, but we want to add 5 millimeters of stock around the edges. Solid Edge Cam Pro now has flat dialog capabilities, and we have customized this dialog so that we only see the information we need. In this case, the Specify Part Boundaries option. Solid Edge Cam Pro is still helping us out. All we need to do is select the top face of each of these bodies, and the boundaries are automatically created. By the way, this custom configuration only took about 3 hours to build, and yet it is simplified to the point that a non-CAM expert can easily operate it. Hey, it's time to generate the operation. As we zoom in, notice how the water jet starts away from each face and then starts cutting? This is so we do not gouge a hole in the body during the piercing operation. Our post-processor will automatically add a dwell at each pierce point. As you know, with CNC machining, the proof is in the G-code. Let's post-process this program now. The advantages we discussed here? No out-of-the-box solution for WaterJet, but we created one in less than a day because of the great customization tools in Solid Edge Cam Pro.
Don't forget, the virtual launch event for Solid Edge is July 15th, 2020. Make sure you save the date and come join us to learn all the great new features in this new release of the product. Also, if you haven't already joined, check out the Solid Edge community forum. You can explore a lot of different topics about Solid Edge and its associated products. You can share knowledge that you have, get your questions answered, and also learn. See the link below. Finally, don't forget you can try Solid Edge for free. We have a 30-day free trial. Just click on the link to download the software. Do you have questions? Thanks.